Okay, so recently we started talking about absolute value inequalities and regular inequalities. So I wanted to go over 4 unique solutions with regular inequalities that may come up. They're a little different, especially when it comes to the compound inequalities. We're looking at and, we're looking at or, and usually the and's right in the middle. Usually the or's going on the outside. But what happens if you have some of those same way graphs or some unique cases where ors are going towards each other, ands are going away? We're gonna look at that right now. So here's the first scenario. I'm jumping right to solutions. I'm assuming you still can solve perfectly fine. But let's say you get this. N is greater than 2 and n is greater than or equal to -1. So what I'm gonna do first is put my thoughts down and then we'll talk about what the actual solution is. If you were gonna graph n greater than 2, you put a 2, open circle, and it would be going to the right. And greater than or equal to -1. Do the solid circle, -1, going to the right. So those are our thoughts. Makes sense, but we're talking and. And is a binding word. It means both things have to happen. Well, if you look at your graph here, they only both happen past the 2. And that's exactly what your graph needs to look like. So when I go to put my final answer, I have to only have the 2 with the open circle going to the right. If you put the -1 up there with the actual closed-in circle, that's wrong. Because when a reader looks at the graph, they should only be seeing answers. So, final answer for this is shading past the 2. That is why the part with the -1 doesn't actually happen. Now let's look at a very similar problem, only with one different word. We have the exact same 2 inequalities, but now it's saying or. So you already know my thoughts. I could be open at 2 going right and close at -1 going right. But the word difference here is so important. Because it says or, if someone asked you, pick a number greater than or equal to -1, or you can pick a number greater than 2. That second suggestion is worthless. You realize that any number greater than 2 is already included in those numbers greater than or equal to -1. And it says or, so we don't need both to happen, we just need one to happen. Well, this set brings nothing more to the table. All of those answers are already included. So our final graphed answer for this one starts at the -1. Closed circle going to the right. Don't put 2 here with an open circle. A reader sees that. Open circles means not an actual solution. And you don't want to give them that bad information. All right, so those are both our same way graphs. Easy cheesy way to remember it. When they're going the same way, and is after or is before. Think about it. All right, next, we have an or. Now again, the typical or, think of it. It could be this or this, and that's exactly what the 2 graphs look like. They go to the right or they go to the left. Well, this one, I'm going to put my thoughts down first. It's saying we're going to be less than 3 or greater than -6. Right? I have a -6 with an open going this way and a 3 open going that way. Now, at first glance, if you're rushing, you're going to look at this and say, oh, it's an and graph and shade in between. Wrong! It's or. If someone asked you, think of a number greater than -6 or less than 3. That's every real number. There's no number that's not included there. So my graph is lit up. It's everything. Everything is a solution to this. So my cheesy way to remember this is called an or towards. Or towards, yeah, fun to say, try it later. Or towards, meaning everything is a solution. All reals. Last one. Now we have very similar, but a little different. Now we're saying we're greater than 3 and less than -6. Let me put my thoughts down. -6, open, and if I'm less than, I'm going that way. 3, open, I'm going this way. Again, if you are rushing, you will look at this and go, great, it's a really good looking or graph. But it's not. It's an and. We already talked about how that is a binding word. So can you think of a number that is both greater than 3 and less than -6? Me neither. If you can, please stop by and see me. But there's no way for you to find a number that does both things. So because neither one of these can happen at the same time, that's your answer. A blank graph. There's actually no number that can satisfy both solutions, and that's why there's no solution. I call this the and away, because it's an and function where they're going away from each other. 4 unique, kind of weird types of solutions you might see out there that you need to be aware of.